next meeting in the Iowa Microsoft Azure user group. So I'll go through our quick slides here. If you want to find us on Meetup to see what presentations we have coming, there's a link to be able to do that. We're available on Twitter, and then as always, we record our meetings and post them out to YouTube shortly after these sessions. Usually within a day, I get them posted out there. So if you have any questions or any feedback for us, by all means, hit any one of us up, Alec, me, Matt, or Bruce, and let us know what questions or concerns you have. We also have our Slack channel, unfortunately, instead of Teams, but we do have a Slack channel out there that you can join. The link's out on Meetup too if you'd like to do that. So I didn't get this updated, but today we're going to be talking about machine learning with Simon. So our training info right there if you're looking for some training. But Simon, you want to go ahead and give an overview of yourself and about your company a little bit, and go ahead and take off on the presentation.
Okay, thank you, Derek. My name is Simon Geletta, and I'm a data scientist. I've been in the data science business for about 30 years now, with analytics jobs in several institutions, several businesses. Currently, I do consulting and service work through my company, Knowledge Delivery Services. My focus is, like I said, it's machine learning, analytics, data warehousing, and that kind of stuff. And more task-wise, platform deployment, integration, and analytic work and machine learning tasks. So with that introduction, I'll just go ahead and start what I wanted to discuss and demonstrate today, which is Azure machine learning. Okay, Azure machine learning is a cloud-based machine learning environment where you can train, deploy, automate, manage, and track machine learning operations. So we have Azure, which is a cloud platform, and machine learning, which is practice. So practicing machine learning on the cloud, particularly the Microsoft Cloud, Azure, that is. What is machine learning? In general, I'm pretty sure everybody has heard that terminology by now. It's a data science technique that allows computers to learn from data and do some work, something like prediction or classification, and so on and so forth. Basically, by learning from raw data, computers can mimic human decision making to perform classifications and predictions and so on and so forth. So today I'll show you a very idealized scenario of creating a machine learning on Azure. So to do that, I will share my screen with you guys so that you can see the environment, because this is a demonstration. So let me see if I can pick the right one here. So hopefully you can see my screen. And this is my Azure Space service. So that's basically where you start. There are lists of resources up here. So I start by creating a new resource, which is machine learning. And I can look for that by name, machine learning. And so start out by creating a machine learning environment, basically. The type of machine learning operation that I'm going to demonstrate today is based on the Machine Learning Studio. Azure allows you to do machine learning in more than one way. They're very flexible, a huge number of ways you can do this, and I'll show you that as I work on this one. So the starting point always is starting with creating the workspace, and your workspace will be created in a service, and you have to create a resource group for your space. So since I don't have a existing resource group, I'll create a new one, MLRG. And the advantage of doing so using a resource group is that you'll basically isolate your resources for this purpose into one area. We'll give a workspace name. We can call it, we could call it whatever we want to. Let me call it demo, because we're creating a demo here. You have to select your region. US Central is good. And your storage account for containers and such. I could leave this as the default, or I can change that name. I'll just leave it as the default to be created. And then key vaults to store such secrets and such for when you want to implement your machine learning solution as an API and so on and so forth. You need APIs, and this is going to be where to keep those resources. Application insights. I'll take everything by default, and then the container registry, there will be container dependent, but I'm not going to create that container right now, because I would like to take advantage of the fact that the container will be created just in time when it starts being used. Okay, so I can just accept all of this and move forward. Public endpoint is important. I'll have that, and I'll have encryption wise, I'll have Microsoft managed keys. I don't need tags for this one. Generally, you might need to create the tags when you create a real-time machine learning environment. So I'll just go ahead and create the environment, and it will take a little time to create. While that is going on, I would like to show you where all this started. Azure ML started in around 2015 with what they called Azure Machine Learning Studio, and which is now called the classic version. I want to show you that environment shortly while our environment is deployed. So you can find that at studio.azureml.net, and it looks like this. If you have an account, then you can log in. And this is what the classic environment looks like. I have several experiments here. And the nice thing is that you can create all of this machine learning pipelines visually without having to do any coding, or with minimal coding. Okay, what I will be demonstrating today would be a no-code solution. That is because it's going to be the simplest, and it's very straightforward. We need to completely create and deploy the entire pipeline within 1 hour, or actually less time period. So that's really the advantage of Azure. Doing machine learning on Azure is that you don't really need to learn code. You need your data science skills and knowledge, and with minimal introduction to Microsoft tools, you can do a full-fledged machine learning operation. And it looks like my environment is deployed successfully. So I'll go to the resource. And here is the overview of the resource based on what the parameters that I provided. The most important thing here is this URL, which is the public interface to the machine learning environment. So I can click on this to go to that environment, or I can copy and bookmark that environment. And here it is. So this is the environment. This is it's called Machine Learning Studio. This is the studio. You can create new resources by choosing whichever approach you do. Notebooks. This environment provides you the opportunity to use notebooks, whether it's a Python or R. It's very simple to just basically spin up a notebook and start working with that right in this environment. Auto ML or automated ML. That is basically usually what you do is you start out with a dev environment, you experiment with your notebooks, developing your code. Once you know that that is working, you can package things and actually farm it to auto ML, and your machine learning algorithm could be recreated and set ready for use through API, and so it will be ready for consumption. Designer, that's really what I am going to show you today. This is a no code or minimum code environment where you can develop a machine learning pipeline. So let's create a new pipeline here. Create a new pipeline. And this is the environment that we have. We've got the canvas here. And you have the objects to work with on this side. And then when you select an object, the details of that object is shown here. But before we proceed, for our demo, we need to create a compute target on which we work. So we need to have a compute target. I'll go to select a compute target here. Since I don't have a compute target, I can create a new one very easily. And I'll just take the one that's recommended for me here. It's a 2 vCPUs, 7 gigabytes of RAM, 8 gigabytes of storage, and so on and so forth. And those are basically the minimum requirements for any data science operation. I can call this demo compute and save that. Okay, will take some time to deploy, so I can wait for that to deploy. While I wait for that, I'll come here, and I would like to show you what the interface of the studio is. Let me select this project. This is basically how you work. Still, this is a classic environment, but basically you get your objects from the left, you drop it on the canvas here, and then you find another object that does some useful data science operation. You connect to it. You start with the data, of course. Any data science or any machine learning operation starts with raw data. So you have to have data, and then you connect that data to different functions. The functions could be some code that you write here. In my case, this is not SAS, an R code that I developed. And today I will not show you any code. I will show you a minimum no code example. So my compute is now deployed. So I'll go and select it. Here it is. And I will save that. And now I have my compute called demo compute available for my work. Like I said, we start with the data. And I'll start with one of the sample data that's available on Azure. And basically what I'll do during my demonstration is create a car price prediction, okay, using several features about cars. Can I predict how much they would cost? So that's the question that I'll be answering, and with what accuracy. So I'll use the automobile price data. I'll use that, and as you can see, the data comes to the canvas here, and the details about the data could be seen here. If I want to actually visualize the data, I can go in there and then visualize the data output. Those are all the fields that are on the data, starting with symboling. So when I click on this, I get the details of that variable here. So that symboling is kind of the ISO rating for each car. Normalized loss, make, and let's look at here, like most of them are Toyotas, Nissan, Mazda. So those are the training data set, raw data set. Fuel type, those are the features that I'll be using to predict price. Make, fuel type, aspiration, whether it's standard or turbo, number of doors, 2 doors, 4 doors, body style, sedan, hatchback, wagon, so on and so forth, and drive wheels, forward, rear, or four wheel. So I have all of those features here. And with all those features, the last one is price. So I'll use all of the variables that are included in the data to predict price. Can I teach the machine by doing that, predicting the price? Can I make the machine learn how to predict the price of a car for which we don't have the price actually? Okay, that's outside this database. So that's basically where we're headed for. As always, one of the important tasks that you need to perform when you do data machine learning is data preparation. Preparation can take a number of things, including, for example, eliminating variables that might adversely affect the analysis, the training. Here, for example, if you look at the normalized losses, you have values NaN, which means missing values, basically not a number. Some values and then not a number. The problem with a lot of missing values like that is that when the computer tries to learn something, it will not know what to do with missing information. So we want to minimize that. So the first thing that we want to do is to use some transformation algorithm to eliminate missing values. Okay, so I just want to get rid of the row, the column altogether, so that it will not adversely affect the data. You can see a lot of transformations that you can do here. I'll just use select column in data set. After I get that, I will connect it to the data, and I'll work with the details on this side. And then I'll say include all columns. Okay, and then exclude that offending variable. So column names, and I want to get rid of normalized loss. So now that column will not be included in the prediction model. Okay. Other variables may also have missing values, not as much as that variable that we just eliminated, but we want to handle those missing values as well. So in order to do that, we look for missing values, a tool that allows us to handle missing values. Should be somewhere in here. If I don't find anything, if it's hard to find, you can just type the name of the object that you're looking for. Missing, plain missing data. I'll take that here and connect it to the data that's that I removed that thing from. And I will here, I'll edit these columns and include all columns. Okay. And this will happen to all columns. And minimum missing values, maximum, I don't want to deal with those. Cleaning mode, I could use custom substitution, or what I really want to do is to not replace the values by anything, but remove the entire row. So if a variable misses some information, I want that entire row to be removed from the operation. Okay, the predictive modeling operation. So I have done fairly important tasks regarding preparing the data. Now it is time to go to the actual modeling. Okay. So what do I need to do to predict? The first thing I need to do is the algorithm. What algorithm am I going to use for prediction? Oh, but before that, actually, before I get to the algorithm, I would like to do one more thing. I need to split the data into a training set and a validation set. So we don't want to train and validate the model on the same data. So I need to split the data. So I'll continue working on looking for variables here. So I'll select split data. Okay. And as you can see here, the clean missing data outputs two types of data sets. On this port, it will output the data without missing values, and on this port, it will output data that have missing cases that are filtered out. So I want to connect this one to the split data. And I will define the split over here. By default, it wants to split 50-50, but for my purpose, I like splitting 70-30. So the first set would be, the training set should be 70% of the data that we have, of the entire data that we have, and the validation set should be 30%. Okay, so again, the training set would be output through this port here, and the validation would be output through this port. Okay. Now that we have gotten there, we have a split. Now it's time to do the algorithm. Okay. So we'll select an algorithm. And for this, I will use the simple linear regression for prediction. It's a very simple prediction method. It takes a set of predictor variables and creating a linear function, it predicts a dependent variable or a target variable. Okay.
Are you choosing linear regression? Yes. Are you choosing linear regression because it's optimal for the problem, or just simple for the demonstration?
Yes, that's a very good question. Usually what you do is you use different models, and there are a huge number of models that you can use, algorithms that you can use that are a lot more powerful than linear regression. Right here, I'm just using a a linear regression because it's the simplest model. It basically predicts, takes a vector of predictor variables and predicts the label using a linear function, which is a very simplistic assumption. But it's also powerful. It's not negligible. Its power is not negligible. But again, we are doing this within 1 hour, so we will not get into model comparisons and picking the right model or creating an ensemble. We will not get into those kind of operations. I'll just assume that, okay, I have determined that linear regression is my algorithm, and then I'm going from there. But that's a very good question. Thank you.
Thank you. Great answer.
Sure. So I have linear regression selected, and now I will select my training model. I will define this algorithm in my training model. So let me clear this and see if we can go into this and actually identify where we get. So the algorithms that I picked came from here, although I selected them up here, you find them here. And then training model, you get in here. And I'll just select train model. And here I will get my data from this training set. Okay, you get the training set. That on this port I said that the training set would be here. I'll tie that to this left-hand side training models, left-hand side. Yeah, so that's oh, sorry. I'll put the model algorithm to the left, and then take the left-hand side of the data and connect it to here. Okay, so that would make my training model. But now we need to define the model will require a dependent variable, a label variable. So I have to define the label. What do I want to use for the label? Select column names, and my label variable is price. Okay, so that completes this. And so I am ready to train based on this data, the 70% of the data that I have, using a linear regression. Predict price. I'm teaching the machine to learn how to predict price based on all the features that I selected in and are available in the data set. Okay. So
it's been a minute since I looked at the terminology machine learning. The label is basically the thing it's trying to predict, right?
Yes, the label is the target that we're trying to predict.
Okay, thanks.
And you want, you're welcome. Thank you for the question. So we use the predictor variables, and then we predict the price based on the choice that we made here about the predictive model. Okay. And after I train the model, I would also need to score the model. Okay. And I score the model based on, remember, the 30% of the data that I put aside here for that purpose. So I will go in here. This is model training, and then I'll go to model scoring. Score model, I select that. You can score a model. This our data is about, continuous surface that we're predicting. And so I'll get the trained model, and not that one. So I also want the the trained model to, I get the parameters from the trained model, and then go back to here, split data, and use the 30% data that's not used for model building for the purpose of scoring. Okay, and after the scoring is done, I would like to evaluate the result. How did my model, how did the machine perform predicting on a new data set? So for that, I will look at evaluate model. So let me see, evaluate model, and so that will come here, and I'll attach that to here. Okay, so I think this is basically the entire pipeline that I'm using today. Like I said, this is an idealized machine learning pipeline. There are a lot of thinkings and contemplations that go into some project like this, especially at the initial time, what kind of data to put together. I'm just using a single data. You probably in real life situation, you collect data from different sources, you combine them, merge them, and then do some data cleaning that's a little more involved than what I just did, and that's how you work. But for this demonstration, this is a pipeline I wanted to demonstrate. So let me submit the job, and then we'll come back to it when it's done. It might actually take some time. I have to give this a name, an experiment name. So call it car price. Sorry, let's call it car dash price. Okay. So submit, and it will start going through the pipeline, starting from top to the bottom. It's submitted. While that is going on, I'll get here and show you different scenarios. On this application, this is, like I said, this is not a no code. I used an R code. This is basically the way you handle that. Some feature of that, I developed this code on my desktop. I have R on my desktop, and I use this flag, Azure, to turn on or off. When it's running on my desktop, this will be false, and all the resources that are on my desktops are used. When this is true, those resources will not be used. This would be used. So, but basically those codes are basically the same. That's usually, if you're coding, this is the way you set up yourself for working on the cloud. Okay. So that's one. And the second thing is this zip file. So when I write this code, I develop custom functions that I use in my code. Those should be zipped up into a zip file and be uploaded into your Azure space and be used for executing your R script. Okay, it is the main R script, and basically that's the way you handle that. When you do coding, I demonstrated no code today, but this is when you do coding. Predictive maintenance, diabetes data. Here I probably show you how you join two data. So this is a diabetic data, hospital discharge data here, and admissions. There are admission codes on this. You map them to their actual language labels by joining these two tables, and you use this tool to do the join. Okay, and you can can use SQL statements, you can use other algorithms to do the join. So there are options. All of these are still functional in the current Azure environment. So let's go back and see if, so it looks like power plan run. It looks like it may have been finished or failed. It failed for some reason in the linear regression. And why would it fail? So obviously for some reason it looks like this may have failed. Might be resources maybe. Let me submit that again, and maybe because I don't see anything that went wrong there. So column selection is running. This one is being queued. In the meantime, if you like to discuss anything or questions, let me see if the chat room. Okay. Selection has completed. Now clean missing data. Okay, split. So as you can see, even for this small workload, it takes time. It's a small machine, and it probably could use some sort of parallel processing to go a little faster. So we are done with splitting the data. Now we are running the algorithm with which we'll train the model. Okay. Now we are training the data. Okay, now we start scoring. So one of the observations through my experience of doing data science is you shouldn't be um, unwilling to watch paint dry when you do works like this, because things take time and just sit there patiently, and but eventually things will get done.
Hey, Simon, can you comment on some of the general purposes you see businesses use machine learning for?
Oh, okay, that's a very good question. So basically, machine learning is a very important tool nowadays for operational intelligence. So businesses generate a lot of data, internal data, through business transactions, and those data are locked in transactional systems. You can offload those into a data warehouse environment and start learning from your history of transactions, including long-term history, by using those algorithms. So that's the simplest way of using machine learning, is train the computer based on your data, your in-house data operations. You can include external data to this by bringing in publicly available data or purchased data. You can use information about your customers. So the method that I'm demonstrating today is a predictive model, in which we predict a continuous variable function. You can also use the same approach for classification. So you can classify, segment your customers. For example, people who have signed up for your service could be segmented into different type of customers, and you can use those feature information that's generated from this to predict what kind of customers you want to go after, and what kind of customers you want to not focus your resources on, so on and so forth. So that this is a very important approach that's currently very successfully used. We live in the age of data, where data are ubiquitous, and businesses leave business transaction information in the form of transactional data, which could be used for operational intelligence. So that's really what this whole thing is all about. Okay, so I think the process is successfully completed now, and our scoring, we can evaluate our scoring results from this evaluation module. So I will go in there and then visualize evaluation results. How did we perform? How did we do in terms of overall prediction? So those are the measures that are used to evaluate prediction. Mean absolute error is 1,773.61. So basically what that means is that the overall total absolute missing, we did not hit the exact amount. It can be quantified using this number. Root mean square error is mean square, the square of those deltas. Here we have absolute delta, of course, but root mean squared is calculated not as an absolute value, but as a sum of squares, which is why we have this. And then relative squared error. So this is this regularized relative absolute error. This one here, regularized. And then coefficient of determination, which is the shows the strengths of the model, the predictive power of the model. So we want a smaller number here, but we want a larger number here. The reason is that what this measures is that the total features that we used explain 87% of the variation in price. So that's a very good predictive power. Although we can push this up to 90 and above, 90%, which means if all the variables that you have in your data set predict 90% of the target, that means that you really don't have to go out and look for more information. 86%, 87% is not bad either. So to get out at how well we did, we can also look at the individual prediction error on individual cars, which is available in this module. So we can look at that. So what is it? So I think it might be here. Yeah, the score. So we look at visualize the score data set, and here are the variables. This is the 30%, by the way. Here are the predictor variables, and here is price, and here is predicted price. So for example, these first three cars, Toyota and Dodge and Volvo. Um, so the price is for Toyota is 9,639, and the model guessed or predicted that it's 10,909. As you can see, there is some error, but not very far. Here we overscored or overestimated the price. For the second one, which I think is Dodge, we under predicted. The price is 6,377. We predicted, the model predicted 5,987. Very close, but so with some error. So you can see Volvo 18,950. The predicted value is 18,032. So that's how you look at this. You can improve this, like I said, by adding more variables or making more transformations. For example, you might want to take one of those variables, wheelbase or length and width, and make some other type of variable out of this. For example, let's take height. Let's say height is one of the variables that we have here. What will happen if we square this value and look at the second degree relationship between the price and height? So there are a number of things that you can do to improve this prediction and move the R square up to 90 and above. So that's what I wanted to demonstrate today. If you have questions, I entertain answering them within the next 3 minutes that we have.
Sure. So in a regression problem like this, right, a lot of the times we want to normalize some of the columns. Is that built into this drag and drop, or do we have to drag it, put in custom code to do something like that?
Very good question. So we have a lot of functions that are built in. As you can see here in the transformations, data transformations, we have 19 functions, 19 different types of things that you can do. Adding columns, adding rows, apply math operations. So this, if your function is just a math function, you can just use this. Apply SQL transformations, so on and so forth. So there are lots of things that you can do here, including regularizing and all the standard procedures that are used in data mining, machine learning. But if you don't find anything here, again, it's very simple to use code, your own code, and include it into this pipeline. Very good question.
And then, yeah, and then after we build it in this model builder here, how do we deploy it?
Oh, very good. Okay, yeah, that's a very good question. I should have addressed that. Once you have your model, you are satisfied with this, then what you do is you publish this as a web service, RESTful web service, and you can actually use API calls through applications like Excel, or even a browser-based application that you create to consume this function. And I didn't think there would be time to show that, demonstrate that, but if that seems to be important, I can demonstrate, I can pick up from where I stopped today and show you how to make this into a web service and then consume it using client applications.
I mean, I would enjoy a part two for sure.
Today we can't, but definitely next time I can do that demonstration here.
And then, sorry, I have one more question.
Sure.
All right, and then on Azure, on AWS, right? We can export those. We can export our trained models of functions, right?
Yes.
And we can download those functions, include them, for example, in an APK or an iOS application.
Correct.
We can run that data directly. Does Azure have the same type of functionality?
Yeah, so you don't have to actually download the data. What you do is
Not the data, the actual trained model. It can be output as a function. That
exactly the parameters, the model parameters can be used to predict new cases that have the same kind of features. So yes, you can create an iOS application or Windows application. I mean a Java application, and then consume this service. So this is, you can deploy this as a service and then consume it through applications. Definitely, yes. That's really where this becomes handy. What I showed you was an exercise of creating the model. Using the model, that's a different thing.
Definitely sounds like we're going to have Simon back for a part 2 of this. So Simon, we'll work with you offline to see about getting something scheduled for the future for that.
Sounds good. I'd be very happy to do that.
Any other questions for Simon?